Question 4. A doctor is studying the scans of 30-week-old fetuses. She takes a random sample of 8 scans and measures the length f millimeters of the leg bone called the femur. She obtains the following results. Show that SFF equals 80. So, we can go to the formula book, which tells us that SXX is calculated by doing the sum of your data squared, subtract the sum of your data, then square it, then divide by n. Now, to put this into SFF notation, we can write this. SFF would be summing up your f data squared and subtracting the sum of your f data, then squared, over n. So now we need to work out what these things are. So first of all, I could work out the sum of the data, which will be me doing 52, add 53, and so on until I add on 62. And if I do that bit in the calculator, that's 52. And be very careful to type it correctly. Add 53, add 56, add 57, and another 57, and 59, and 60, and 62. So that's 456. Next, I'm going to work out the sum of my data squared. So that's 52 squared, add 53 squared, and so on until I get to 62 squared. Now I can go in here and put the squareds on. And now I get 26,072. And also I know that n is 8 because there are 8 pieces of data. So now I can work out SFF by taking this number, 26,072, and subtracting this number squared over 8. So I've already got the 26,001 in my calculator, so I just press take away, so it's going to do answer, take away, and I'll open up a fraction, 456 squared, make sure it's only the top line that's squared, over 8, and I get 80, which I was told to get, so I can write quite easily done. And I've proved it for 3 marks. The doctor also measures the head circumference h of each fetus, and her results are summarised using these statistics. So now we've got to use those numbers to find SHH. So they've done the hard work for us here. We're going to use the sum of the data squared minus the sum of the data then squared over n. And let me move that up now. So we need to put the numbers in. Sum of the data squared is, is 610,463. Take away the sum of h, 2,209 squared over 8. That into my calculator, 610463. Now there'll be nothing to check that I've done this one right, so I better check it carefully. Take away 2209 squared over 8. And that is 502.875, and we can give that to 3 significant figures. But I will keep the accurate one in my calculator for the next bit of working out if I need to use it. So part C says calculate the product moment correlation coefficient between the length of the femur, which is f, and the head circumference for these data. So the formula book gives you this for calculating r. So we can translate that into the names of our variables. So this will be SFH over the square root of SFF times SHH, and the top number SFH is given here 182, and we're dividing by the square root of SFF. We had to show that that was 80, and SHH is what we just worked out, and we're going to use the fully accurate one. Should always do that. Now we go to the calculator, and I type 182 over the square root of 80 multiplied by the answer. Make sure that the square root goes over the whole of the denominator, and that gives 0.90739, and thankfully it's between -1 and 1, so that's fairly reassuring, and that's 0.907 correct to 3 significant figures. Now, the doctor believes that there is a linear relationship between the length of the femur and the head circumference of a 30-week-old fetus. State, giving a reason, whether or not your calculation in part C supports the doctor's belief. So, if there was a linear relationship, then the product moment correlation coefficient records to us whether there is a linear relationship or not, and the strength of it. Now, if this had been, say, 0.1, that wouldn't really be showing much at all, but because it's so close to 1, or it could have also been close to -1 if it had happened to be a negative linear relationship, that really is suggesting that there is a relationship there. So we have to think how to word it. So we could say the calculation in part C indicates a strong, important that it's strong, positive relationship between F and H, which supports the doctor's belief. Part E, find an equation of the regression line of H on F. So F is the independent one, that's our X, which is the way we set it up, and H is the response variable Y. If we're asked for H on F, it's like Y on X. So for this, we need to use this information from the formula sheet. This would be the linear relationship, but for us, X is F, the length of the femur, and Y is H, which was the circumference, the head circumference. So we need to calculate A and B. So you have to find B first, because you use B to find A. So to find B, we're going to need to do S, F, H, so I'm replacing the letters out, over S, F, F. It's for this part that you need to have made sure you know which one's X and which one's Y, otherwise you wouldn't know which number to use for the denominator. So SFH was the one given in part C as 182, and SFF is the one that we had to prove that was 80 earlier. So that gives us 182 over 80, which is 91 over 40, or 2.275. And often when A and B, typically when A and B are given in the regression line, they are actually given to 4 significant figures, and this has come out with 4 significant figures by itself. Now to find A, we can do Y bar, which in our case would be H bar, which is the mean of the head circumferences, subtract the value of B multiplied by Rx, which is F bar, which is the mean of the length of the femurs. So now I can substitute numbers into there. To get H bar, I need the sum of H. Do I have that? Yes. The sum of H is 2209 divided by the number of pieces of data, which is 8. Subtract B, which is 91 over 40, multiplied with F bar, which is the sum of F, which we worked out right up here as 456, over 8. So now I need to put that into the calculator, which is 146.45, and we can use that to write our regression line. Now I did just check the mark scheme, and they've actually put A and B into as 3 significant figures each, which at least matches the rules that we use elsewhere. So let me find somewhere to write. Here we go. So looking back at this, we're going to be writing H equals A plus BF, but now I'm going to be substituting A and B into 3 significant figures. So that gives me H equals 146 plus 2.28F. And this is the correct answer. Okay, let's take a look at the final part. The doctor plans in future to measure the femur length F and then use the regression line, which would be this, to estimate the corresponding head circumference. A statistician points out that there will always be the chance of an error between the true head circumference and the estimated value of the head circumference. Given that the error E has the normal distribution, so this is part F now, given that the error E in millimeters, so how many millimeters from the truth, has the normal distribution with mean 0 and a standard deviation 4 and variance 16, find the probability that the estimate is within 3 millimeters of the true value. So if I drew the variable E, which is normally distributed with a mean of 0 and a standard deviation of 4, so by 3 standard deviations from the mean, so this would be 4, 8, 12, and this would be to negative 12. Find the probability the estimate is within 3 millimeters of the true value. So that's like saying E would be somewhere between -3 and 3. So we're looking for this, what number goes in there. So this is, we can't look these numbers up from the Z table, so what I would need to do is transform those numbers into the standard normal distribution numbers. So it would still be centered on 0, but this time the spread would be from -1 to 1. If I transform this number 3 to a Z value, to find the Z value, I would take the E value, subtract the mean and divide by the standard deviation. Well, in this case it would be 3, take away the mean doesn't do anything, but dividing by the standard deviation of 4 would give me 3/4 or 0.75, and so on the other side symmetrically it would be -0.75. If I look up 0.75 in the tables, I get 0.7734, which is all the way up to here. Now I want to know altogether about this gap. There are a few ways you could do this, but one of them would be to find out just this section by saying that if all the way up to here is 0.7734 and then up to here is 0.5, then I can work out that section by doing 0.7734 by looking this up in the Z tables, and then subtracting off 0.5 to give me 0.2734. And now I don't just want that part, I want it doubled. I want this part as well, symmetrically the same. And so I can finish off by doing 2 lots of 0.2734 which is 0.5468.